Yeah, like if you think about it, we've done geometry, combinatorics, and we've done, would you say we've done algebra? Did we do algebra? Hmm. Yeah, like the one with like this would be like considered combinatorics. Yeah. Or like this would be sort of like combinatorics, you know? Hmm. This is geometry. So it seems like we're going to do algebra and number theory all in one go here. Now this is maybe this is a good problem for us because you don't expect to solve it in like 20 minutes, but we can definitely learn some things. Does the question make sense? Does the question make sense?
Yeah.
So you got m cubed plus n cubed, and they don't share any factors basically. And you wanted to divide, so you want that to be a factor of m squared plus 2mn plus n squared. You know? And I guess the idea is like if m and n get big, okay, the cube is gonna get much bigger than the square. Does that make sense? Like if you have 100, then 100 cubed is like what's 100 cubed?
100 times bigger than 100 squared.
Yeah, it's 100 times bigger than 100 squared. Yeah. So it becomes impossible for this big number to divide into the smaller number later. So so then it's conceivable we can find all the possible things for which this divides us. They have to be all smaller than something. Hmm. Okay, maybe you guys can learn something about factorization. Do you know factorization in algebra? Do you know like m cubed plus n cubed factorizes as something? Hmm. Do you know factorizes as something? Have you heard of sum of two cubes? Huh?
No.
Like you've heard of difference of two squares, right? Difference of two squares, sum of two cubes. It's kind of like the same family of factorizations. M plus n. And like these one, the factorization always seems magical, but to check it, it's always just trivial. So, have you seen this one? Okay. And do you know how to? So we can't really factorize this, but we do have like, for example, m plus n squared, right? Equals m squared plus 2mn. I'm kind of just live doing this now, I guess, but I haven't seen this problem before. I think it's more interesting when I haven't seen the problem before, because then you kind of get an idea what it's like instead of someone just pretending they solved the problem. All right, so that's equal to that, and then there's like another 18mn, right? So this is So this is equal to m plus n squared plus 18mn. Yeah. Yeah. So one thing that might be nice to investigate is like if this thing divides into that thing, right? Then this thing should also divide into it, right? Because that's a factor. So like this divides into that, and that divides into that, so this divides into that. You know? Okay, but the nice thing about this is if that divides into that, like we know m plus n divides into m plus n squared, right? So so if the whole thing is a multiple of m plus n, and this is already a multiple of m plus n, then the 18n must also be a multiple of m plus n. You know? So we say m plus n divides 18mn. Yep. So this is already pretty good, I think. Yeah, you can learn a bit about number theory. You might call this algebra. Yeah, the maths curriculum is kind of weird because like people make it all these topics, but like when you do lots of maths, you end up kind of blurring the boundaries between the topics. You never really learn algebra or Olympiad maths, even though it's like the biggest topic in both Olympiad maths and like school maths is basically just all algebra. But you rarely apply the algebra to number theory. So then it becomes a sort of like a number theory topic. Okay, some basic facts maybe you can try to prove is, so does m plus n share common factors with m? Hmm? Oh, do you know this? Does m plus n and m have any common factors? Does that make sense, the question? Can m plus n and m have common factors? And like, what's the reason for the answer as well? You know, it's weird. We got stuck on the first problem for like an hour and a half, and we solved the second problem in like 5 minutes.
I mean, Ian did say he's got 2.
Yeah, but he skipped one, so we don't know. He's a little bit mentally weak, so he could give up at various times. I would like to think he tried a long time before he gave up, but the reality may not support my wishes. Well, it'd be worse for the score in the exam, maybe, because like you waste less time for a problem you don't score on anyway, right? But in the long run, it's it's the grit that we want. You understand? The championship instincts, the perseverance, these human qualities that we all admire. Hmm. Yeah, there's actually. So can you explain if m plus n and m have any common factors? Are you guys thinking about that right now? Okay. I feel like you both are just drawing wings on previous pictures you've drawn. Maybe that is the time of the day it is. But, okay. See, if m and n share a fact, if we know m and n don't share any factors, right? So imagine if m plus n shared factors with m, okay? So like, let's say they're both multiples of d, okay? If they're both multiples of d, right? And we know m is a multiple of d, then that means n is a multiple of d, right? Joshua's just not listening at all. Hmm. Well, I still like this version of expired Joshua. Just kind of chill.
What happened?
You've expired, clearly. Yes. Okay. So can you see, therefore, they don't have any common factors, right? Okay. So if m plus n doesn't share any factors at all with m or n, right? It's the same reasoning for n, right? They're asymmetrical, yeah? Then all of its factors must be in 18, yeah? So then m plus n divides 18, yeah? Can you see that solves the problem? Because there's not many numbers that divide 18, right?
1, 2, 3, 6, 9, 18.
So what are the factors of 18?
1,
1,
2, 3, 6, 9, 18.
6, 9, 18, yeah? So that's 6 cases for us to do. Okay, and m plus n can't be 1, right? Do you know why? Right, maybe we can do these cases together. Well, you can do them. You have paper? Maybe not. I don't have enough paper, that's the problem. We're using the old. I do have paper. Okay. Alright, anyone done any cases? So m plus n is either 1, 2, 3, 6, 9, or 18.
Oh, we're trying to.
Yeah.
Oh.
You can probably rewrite this as m plus n. Oh, wait. It's all squared minus 3mn or something. Minus the squared minus 3mn. Is that helpful? So I'll cross out the ones I've done. Hmm. 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 What's the one? If m equals 1, n equals 5, what happens? What's 5? It's like 126 divides 126. It actually works. That's amazing. Does it work? It always works if it's 1. So 1, 5, 5, 1. No, one of them's 1. Mm. Okay, then m is 2, n equals 4. M equals 2, n equals 4. So 2, 4 is 8 plus 64. 72. 72 go into, it's 2 squared plus 4 squared. 20 plus 160. What? 2, 16, 20, 180. 72 go into 180? Doesn't seem to. And we just got 9 and 18 left. These seem harder. 1 plus 1 equals 18. Maybe it's easier to keep them in factored form. So you have 18 times m squared minus mn plus n squared divides into 18 squared plus 18mn. So you really just want m squared minus mn plus n squared divides into 18 plus mn. It's not going to be easy to do. So they can't really be co-prime. So m and n have to be factors. This is right. This is 18 squared minus 3mn. Does that help? So that's divisible by 3. M and n have to be divisible by 3. One of m and n has to be divisible by 3. Which means that, if one is divisible by 3, then the other is as well. That's definitely true. And then, it's divisible by 9. They're both divisible by 9. That's crazy. Right. Get what I'm saying? So if m plus n is 18, right? Then we get this thing here. We get this thing here divides into 18 plus mn. Yeah. Okay, but this thing here is a multiple of 3. Yeah. That means 3 divides into that. But 18 is a multiple of 3. So that means 3 divides into mn. Okay, if 3 divides into mn, it divides into m or n. Okay. If 3 divides into m, for example, because m plus n equals 18, it has to also divide into n. So 3 divides into both. Yeah. So 9 divides into mn. Yeah. Okay, so we can kind of cancel out the 9. If we cancel out the 9, so we get, so instead of 18 times 18, we have 18 times 2 minus 3, and then we have the, m and m prime with the 9s cancelled out, yeah? That divides into 18 plus, so the 9's cancelled out, is 2 plus m prime n prime. Okay. Okay, so now what we have is wait, for m and n to be both divisible by 9, that means they're both equal to 9, right? That's kind of simple. So this is just 1. So we have 36 minus 3, which is 33, divides into 3, which is not true, right? Actually, hold on, no. This is dividing by 3, sorry, I made a mistake. It's not dividing by 9. Each one is, we divide both the product by 9, but each one's divided by 3. Okay, so they don't necessarily have to be multiples of 9. Okay, but if you add 2 to it, it's a multiple of 3. Yeah, so what are the possibilities of their multiples 3? Like, m could be like 3, n is 15, yeah? It's like 3, 15. M could be like 6, 12. Or we know it's not 9, 9. I checked that before. And then it just is symmetric, right? Okay, I guess the problem is if you have a multiple of 3 plus 2, it's not a multiple of 3, right? But we're saying it's divisible by 3. Yeah? So that can't happen. So I think 18 is out. No? There's just 9 left. We can take our time to do 9. Okay, maybe we can't. Yeah, so if m plus n equals 9, right? And this is 9 times, I guess 9 squared minus 3mn, yeah? Divides into 9 squared plus 18mn, yeah? And we see that there's like a 9 that cancels immediately, yeah? So it's actually 9 squared minus 3mn divided into 9 plus 2mn. Yeah. Okay, so the same argument applies again. See, so this is a multiple of 3, right? And that's a multiple of 3. So then one of these has to be a multiple of 3. And since they add up to 9, they both have to be multiples of 3. Yeah? So if they're both multiples of 3 add up to 9, it's really literally just 3 plus 6, right? So you could just divide out by the 3's. So then you get so the 9 minus 3m prime n prime divides 1 plus 2m prime n prime. Okay. Yeah, and so there's the same problem again, because then you have m and n, m prime and n prime, they're like, basically 2 and 1 or something. Right, so if m prime and n prime are 2 and 1, then 5 is not a multiple of 3, so that's like a problem. Yeah? Yeah, so if it's 2 and 1, then we really have 3 divides into 5. Yeah? Which is not true. Well, I guess we don't have 9 either. Alright. So these are the solutions, I guess, as far as what we got. Yeah. Did you wait? How long did it take you to do this number 3 one?
Half an hour.
Did you get the same answers, or did we miss something?
I don't think you missed that.
You got the same as us.
But yeah.
Did you get m plus n divides 18?
Yeah. And then you just check cases.
And did you check the m plus n equals 18 and 9 cases quickly? Or
18
slowly?
and 9. Oh. Just slowly. There's like no cases left. It's like 18 with like 3 cases. And even then,
Did you get the multiples of 3?
what?
Like, how did you do the 18 case? How did you do the 9 case?
9.
I guess the smaller cases are all just trivial.
Yeah.
It's just 9 and 18.
The 18 case is like not that bad. Just check like
Did you get that there were multiples of 3?
which one?
Like the 18, m and n.
Oh. That's an idea. Because 18 you had like 3 cases.
3
You had
cases.
like 117. And you didn't have to worry about like up to like 5 something.
Oh, really?
You had very few cases. Because then you just rule out the non-co-prime. Because like the cases have to be
Oh, they have to be co-prime, that's right.
yeah, so you get left with
Oh, so we were already done when we said there were multiples of 3.
yeah.
I said, okay, so we actually could eliminate the cases super fast. Because once it's 18, you got 3 divides m or n.
Yeah.
And so therefore it divides both.
Oh,
And then it's finished. Yeah.
yeah.
Because m and n are co-prime. Okay, so that's how we could improve.
Oh yeah,
So-
then you get 3 divides.
Same with 9. Yeah. We've got 3 divides 9 and they have to be co-prime. Yeah. Yeah, and then we didn't even have to consider this 2 and 4 case. Because they're not co-prime.
Yeah.
Okay. Alright, good. Yeah. We solved this one in like 5 minutes.
Yeah.
And it's stuck on the first one.
The first one's like
Oh, I feel like you should have got it still.
really?
Yeah.